right, pre-calculus 6.1, day 1, we're going to look at law of sines. You have right triangle trig, where you have to have a triangle that has a right angle, SOHCAHTOA, sines opposite of hypotenuse, cosines adjacent of hypotenuse, etc. But then what do we do for solving for sides and angles when you do not have a right angle? And so we're going to be starting with law of sines. We'll also have a law of cosines that allows us to find missing pieces of triangles when they are not right triangles. So we're going to be using the law of sines to solve oblique triangles. That just means triangles where the sides are not all the same. And back reviewing some stuff from geometry, angle, angle, side, angle. Congruency theorems from geometry. And side, side, angle, we'll be looking at that some more, well, a little today, but more tomorrow. And we'll be looking at finding the area and how that formula works. There's a new area formula when you know two sides and an included angle. So here we go. We have a triangle with sides A, B, and C. And one thing you need to know is the standard labeling of a triangle. When you have capital A, capital B, capital C, the sides opposite are going to be labeled A, B, and lowercase c. So the side opposite A is little a, side opposite angle B is little b, and side opposite C is little c. That's our standard labeling of a triangle. And the law of sines is that these three ratios are equal. A to sine of A, B to sine of B, and C to sine of C. So those are all the same ratios. And so, just a minute. Emma, could I have you shut the door for me, please? Thank you. Sorry about that. Thank you, Emma. Just waiting. Thank you. All right, so anyways, we set up these ratios. Make sure, since we are given the angles in degrees, that your calculator gets fit to degrees. And so it is just, the length of A to the sine of A is the same ratio as the length of B is to the sine of B, is the same ratio as the length of C is to angle C. And you don't have to, you just work with the information you have and set this up. Hopefully you have 3 items and you're looking for a 4th that fits in there. So what does that look like? Well, draw the standard triangle. And I am notorious. I don't sit there and try to draw it to scale. I just go A, B, C. And then they say that angle A is 35 degrees, angle B is 50 degrees, and little a, so the side opposite angle A, is 16 feet. So they say find the remaining angles and sides. They might also just say solve the triangle. When they say solve the triangle, find all the other missing pieces. And the measure of angle C should be easy because the sum of the angles of a triangle add up to 180. So you just need to add up 35 and 50, which is 85, and subtract. And the measure of angle C is 95 degrees. I want a solution box. And so one of them is the measure of angle C is 95, and put a degree symbol on that. So you have 3 missing pieces. You had the measure of angle C, and then you have little c, and you have little b that are missing. And we just found out that C is 95 degrees. So over here, you're going to need to find C, and you're going to find B. And those will be approximated. So the law of sines is I take the side length over the sine of the angle. This is the only pair where I have a side and an angle. So I'm going to use those. And so it's 16 is to the sine of 35 degrees. And then I choose what I'm going to find next. Well, if I use B, then that is to the sine of 50 degrees. And to solve for B, then, you are just going to multiply by the sine of 50 degrees. And those cancel. I'm going to put B on the left. And you're just going to take 16 times the sine of 50 degrees and divide by the sine of 35 degrees. So take out your calculator, and we're just going to, what do we have? 16 sine of 50. And divide that by sine of 35. But make sure that your calculator is in degrees. I have degrees highlighted in Desmos, and it's evaluated. And I have a tendency to write that out to at least 5 decimals for right now. Just in case I decide to use it to find something else. But in my answer box, I will go to rounding it to 3 decimal places. And then we do the same thing to find little c. 16 is to the sine of 35 degrees, as little c is to the sine of 95 degrees. Again, I'm going to use the one that they gave me rather than having to repeat. I mean, I could put b over the sine of 50, but that's something I calculated. I don't really have to use it. So I prefer to stick with what they gave me. So I'd rather use 16 over the sine of 35 is as c is to the sine of 95 degrees. And once again, you multiply both sides by sine of 95, and c is 16 times the sine of 95 degrees. So again, go to calculate it. And I can just come up here, probably, and maybe edit it. So sine of 95. And I already have the sine of 35, and there it is. And that's the last thing I'm going to calculate, so I don't have to write out 5 decimals. I'm done at that point. I have found all 3 missing pieces. And so I definitely want to have organized work. So basically right here, I have a column where I found C. Here I have a column where I found B. Here I have a column where I found C, and I have a box where I can see all 3 pieces that are found. So organize it so that it's readable, that it's not kind of scattered all over the place. All right, so then, by the way, they gave us the 35, the 50, and the 16. And that is an angle, side situation. And in geometry, you learned that if 2 angles in a not included side of one triangle are congruent to 2 angles in a not included side on another, that those 2 triangles are congruent. And what that means is there is only one triangle that has these measurements. Tomorrow we're going to get into what's called the ambiguous case, where there could be a second triangle, but we're not doing that today. But that's angle, side, and that was noted up here. All right, so for the next one, when I do my triangle in standard position, and again, I don't worry about if the angle's obtuse, acute, I just draw the same triangle, and I put in the information given. So there's 40 degrees, 20. Oh, I did forget to put the units up here of feet. All right, so 20 meters is little a, little b is 12 meters. And this is side-side angle. And so we are just going to set up 20 is to the sine of 40 degrees, as 12 is to the sine of b. And that's pretty much the first thing that I have to do, because I have this side and its opposite angle, and I don't have another angle to find a third angle, and I have this side, so the first thing I'm going to have to find is the measure of angle B. Now, you can flip the law of sines. It's a property of proportions. You can put the angle on top and the sides on the bottom, and it's the same proportion. And then this is just a nice thing to do because I can multiply both sides by 12. And then I have the sine of b is 12 times the sine of 40 degrees all over 20. But now we need to find the angle, and that's an inverse trig function. You need to take the inverse sine of this in order to find the measure of angle B. So make sure your calculator is in degrees. And I need to find the inverse sine. Oops, I guess I need to clear first. And then I can do this just 12 sine 40 divided by 20. And I'm going to need to use the measure of angle B to find the measure of angle C. So I'm going to write out a few extra decimal places. And put a degree on that because that is the measure of angle B. And so now that we know angle B, we can find the measure of angle C by taking 180 degrees minus 40 degrees plus 22.68550. And that will be approximated, and it comes out to 117.31450. And I want some extra decimal places on it because I have to use that angle to find little c. If I only go to 3 sig figs on that of accuracy, I won't be guaranteed to be, 3 decimal places. I won't be guaranteed to be accurate to 3 decimal places on my final answer. So now the c is that, and I need to find little c. So I'm going to set up that 20 is to the sine of 40 degrees, as little c is to the sine of 117.31450. And again, that's now going to be approximated. And c becomes 20 times that sine over the sine of 40 degrees. You need these extra decimal places. If you only use 3, you very likely will not be correct to 3 in your final answer. And so now it's a matter of putting that in and calculating it. And there you have little c. And this is the last thing you're finding, so you can go ahead and just round that to 3 sig figs. And then I want your answer box. So we found the measure of angle B. And I'm going to 3 decimal places, normal rounding rules, measure of angle C. And then little c. And that has the units of meters on it. So this law of sines, you can flip all the fractions. And so when you know you want to find an angle, it's easier if you put the sine of the angles in the numerator. This right here, you can just flip all the fractions. It's the same sine of A over A as the sine of B over B as the sine of C over little c. So if you know the first thing you're trying to find is an angle, you can plug it in directly into that flipped fraction. If you're finding a side, it's easier to use the other. All right, so then we have the back side. I think. It's interesting, it doesn't want to show that there. Now I've got it. Okay. All right. Because prevailing winds, a tree grew so that it was leaning 3 degrees from the vertical towards the person. So I'm quite the artist. There's my person. And so the tree is leaning 3 degrees, which means from here to here is 3 degrees. And the person is 20 meters from the base. And so the angle of elevation, and that's this angle right here, is 28 degrees. Find the height of the tree, and it's really how tall is it? I don't know. It's semantics, but what they want is this height right here. They want to know what that height is. Well, this, if it wasn't leaning 3 degrees from the prevailing winds, you would have a right angle with the ground. So that being 3 degrees makes this 87. 90 minus 3 is 87 degrees. And in all of these, they're basically giving you information so that you can find what they're asking for using law of sines. And it doesn't really matter what's A, what's B, what's C, but I'll label it. And so I need to find the measure of angle B because I only know one side, and I want to set 20 meters to the sine of angle B. So find angle B by subtracting from 180. And it's 65 degrees. And I just want the height of the tree, so I only need to set up one proportion. I want to find x. It's a side, so I'm going to put the sides on top. So 20 is to B is 65 degrees, the sine of 65. As x, the height, is to the sine of 28. And again, you're going to get 20 times the sine of 28 degrees all over the sine of 65 degrees. And I've shown calculating that. I don't think we have to show it. It comes out to 10.36. It rounds to a 0, and you do need that. And your units are meters. So that is your height of your tree. And then we're going to come up with a new formula for an area of an oblique triangle, depending on what you have. Right now, for you to find the area of a triangle, you need the altitude to the base. And so the area of this triangle would be 1/2 of C times H. But we are going to show that if you know two sides and the measure of the included angle, this would be the included angle, you can get the area by taking half of the product of the two sides times the sine of that angle. And that's true for any of the three sides. As long as you have the two sides and the included angle, the area is going to be 1/2 their product times sine of 50. And where does that come from? Well, it comes from this area formula, but this is where the height is an altitude. For instance, right here, we would say that the area is 1/2 C times H, because the base is C and the height is H. But we can use the fact that this is a right triangle and that the sine of angle A is H over B. Because sine is opposite over hypotenuse, and this is a right triangle, so I can use SOHCAHTOA. And if I solve that for height, I get that the height is B times the sine of A. And so I'm going to substitute that in for height right here. And so this is the area, but the area then can be 1/2 of C times B times the sine of angle A. And notice that B is this side, C is this entire side, and angle A is the included angle in between them. And we can similarly show this for the two included sides of each of the individual angles A, B, and C. This one was just for angle A. But anytime you have the two sides that include the angle, the area is just 1/2 their product times the sine of 50. And so here they're just showing it for the standard triangle, the three different formulas. I don't think of it as three different formulas. It's just you need the two sides that include, that they make up that angle, and then that's going to be your area. So this is the formula we want you to use. Find the area of a triangular lot containing side lengths that measure 84, 55, and form an angle of 115 degrees. So again, I guess this would be 84, this would be 50. I don't worry really too much about that. But the idea, they form that angle, this area is 1/2, 55 times 84, and then times the sine of 115 degrees. And just multiply that out and to 3 decimal places, 571. And area is square units. So if the sides are yards, this is yard squared. Square yards. That's it.